Once you have the image file, you can look at the desktop of the image file. You can find the instruction file from the desktop, and you have the instruction of tutorial today of the day. So let's get started. So what we're going to do is multi-camera system, especially eye-to-hand systems, which can form so many scenarios like. Mentioned just now the point cloud stitching and image stitching. It will produce a whole environment of the robot itself. Yeah. So next thing is the outline. So first is ROS Industrial. ROS Industrial is, we are not cover everything of ROS Industrial. We just using the robot of ROS Industrial, like the universal robot that mentioned later, this one, and the RGBD cameras. And after that, the whole setup in gazebo. So we will produce the eye-to-hand systems to the gazebo, in the gazebo. And after that, I would teach you guys how to add in a sensor, a very basic move. Like, and after that, you have the camera image and what to do next. So ROS Industrial is actually a robot, open source from ROS, and it advanced it to the industrial level. So it can manipulate the actual automation and the robot itself. I mean the actual robots. After that, so it will provide so many interfaces like for you guys to actually manipulate the robots, and so many software and libraries to cover, to specify for the 3D or 2D sensors, path planning, and scan and pen, and so on. So you can see this is really basic ROS layers of these two. So, and the others is the ROS Industrial advanced from the ROS. So it has a hidden name called ROS I, which is from the ROS Industrial, and you can see the middle part is move-it layer that is introduced by Professor last 2 weeks ago. So it can actually manipulate the robot from the gazebo and can manipulate the robot. So this is a ROS interface layer, which can directly communicate with the robots. And these two main things that I'm going to use to fulfill my my goal with eye-to-hand systems. So first is universal robot with UR3 is 3 kilogram payloads, and RGBD cameras with action probes. I use 3 of it. This is the whole setup of the gazebo. I just this showing to because print screen it from a couple of weeks ago, so I'm giving you guys the 3 RGBD versions. So the next thing is how you're gonna add the sensor to the gazebo. So first thing first, what is URDF? URDF is a universal robot description file format. So it is a XML file format which describes all the elements of the robots. Every single element will be described from in this file, and you read the gazebo will read this URDF file to produce the 3D environment. First, you have to include the sensor URDF to the actual robot URDF. So, and secondly, you have to declare the parameters for the sensor. You guys can go to this path, like project hacking source, universal robot, UR description, to see the URDF file of the robot itself. Include some folder like the UR robot gazebo file inside, and the UR3 URDF, of course, and the checkerboard. The checkerboard I'm going to use in this project is AirProtect. So I'm included like as a URDF file, and then the RGB folder like behind below that. So this is a URDF, the RGBD sensors, right? And then define the RGBD sensors as this parameter from the URDF file. You guys can go to the same URDF, the path, like go to the sensors and look at the action pro like URDF. And this is the way to declare the action pro. We receive the name, parents, origin, and optical origin. name is obviously the name of the RGBD, and the parent is the origin parents, and then the origin of your URDF according to the relative to the base, and then the optical origins, which mean the origin that is of the site. Yeah. So I've included 3 RGBDs here, which you can see there's a different origin, which mean the different position and the rotation of it. And RPY means here is rotation view for the really basic XYZ rotations. And after that, the whole system is built up. Like you have aerotags, UR3 robots, and cameras. So what we're going to do is receive the image from the RGBD, which means the scenario of this whole system, and then do some image processing. What we're going to do is Apple tag detection. So Apple tag detection is mainly doing 3 things. One is subscribe the image from the cameras, and then process detections and some algorithm of the Apple tag detections, and then publish the image and process of it. So manage these 3 things: subscribe, detect, and publish. Yeah. So next thing I'm going to introduce you to explain how the Apple tag detector works. This Apple tag detector, this library is from the creator itself, which is awesome. So Apple awesome. Couple of steps, with 9 steps of it, the Apple tag. First is pre-processing, as you guys know. Pre-processing, convert it to the grayscale. After that, apply a Gaussian filter to enhance the outline. And then you have the pre-processed image, which means converted image. Then you have to calculate the local gradient of it, which means every single pixel's gradient, which means you have every pixel's magnitude and the direction. And according to the similar direction, you will find the list of edges. And according to the edges, you will find cluster of the edges. Look over the clusters, you will fit in the lines which is called segment. This line fitting is called segment. So for each segment, each segment begins with connected segments, and with, like, let's say the segments begin in these directions and be connected to these segments in this direction. It is connected. So you will find a part of it which is called a segment with length 4 width, and you start decode the load of it. And after that, you decode the quad inside. You will generate a list of the tag detections. And after that, you will find this detection and compare every single one. You will find the least error handling distance from your image to according to the list of the tag detections. Let's get started to run the code. So you see in the Gazebo file, we will produce a UR3 robots, Apple tags, and 3 cameras. And after that, you launch the Apple tag detector. And then it will show you in Argus. And the Argus will show you the every orientation and the relative position of every single camera.